Emacs has, and there are other programs that know how to parse the CScope database.
Excellent. This is a great project. Thank you so much.
You're welcome.
All set? Hi. Thanks for waking up early on this Sunday to meet with us. I know that's a challenge. Okay, can you tell us a bit about your poster?
Well, my name is Portante. I work for Red Hat, and back when I was learning Python in 2008, being used to C, I used CScope to look at big source code projects and to introspect and figure out what symbols go where and who calls what, etc. And there was something like that out there called PyCScope that I took and extended, and as I was extending it to do what I had done under C, I learned a little bit more about Python and how it's done. So I decided to do a poster on what it took to do all this and what is a PyCScope and how it works. And so what this is all about is there's a small 4-line Python program right here. And this is the AST tree that's generated by the parser for that 4-line program. And what I'm doing is I'm sort of breaking it down. This is how I learned the AST tree and what was going on. I broke it down into sort of the, collapsing these big boxes. Basically, it's a file with 2 statements, file input and there's standard in input, etc. A new line in the end of the file. And each of these statements, this simple statement I blew up, and what is a statement? It's just an import on one line. And then there's an expression statement, which is just test equals something. And so what I've done over here is on the outside of the poster is the actual code broken out into what it's doing, and then to show what the code is doing, I wrote a state diagram that talks about how it works. So, excuse me, when you come in, the first thing that's done is as you're walking the AST tree, you run into that import name, and then that sets it into this import statement, and then that moves to where you see the dotted as names, which comes in here, and then that gets you into state where you're now going to be marking the next symbol as imported sys, because in CScope you could say find all includes, and so you can use this as like an include, if you will. And then following that is that next line, so consume the new lines, and then we move to an assignment statement when we see the expression a test and an equal, and then here we consume tokens marking the A as a symbol, exiting the state when we hit the equal sign, we see the number, we consume it, and that's the end. So it's it's a lot of stuff because it's sort of complicated as it is. Obviously this goes bigger programs. And this is sort of an example of the CScope program itself, Python program that's been broken down, and I went and looked to see what symbols are being assigned to this, what values are being assigned to the symbol mark as it goes, and just sort of highlighting as an example of what that is.
Excellent. Can you show me an example in some of this code of typecasting? I'm not seeing any of that. Is it part of this process that you examine, or is it not part of it?
I don't do any typecasting in here. I'm just working with the AST tree as it stands, and I have not sort of explored into more Pythonic things that are happening. I've stayed at the CScope level of things, which in CScope you don't get any of that stuff when you're working on that. But what I did do was extend it to add strings as symbols, because one of the things I found in Python programs is sometimes, if you can imagine this as a function call, people pass strings of the function name in a string. And it drove me crazy because I wouldn't find a symbol, but it was actually done as a string. So I added an option so that you can look for strings that are valid symbols in your list, just in case you're not finding a string. And then assignment marking is new. This is actually something that was added recently. It's not in upstream CScope, so I added that into a branch of CScope. And then this whole imports as includes wasn't doing from statements. It was just doing the import statements, like import sys. So I added that. Dean Hall was the original author of PyCScope 03. He had a lot of unit tests, but I expanded the unit tests, and then I posted up on GitHub at PyCScope.
So it behaves almost the same way as the original CScope, the AT version going way back?
Yes, exactly, but on Python source.
Oh, so that's beautiful.
So I can take a big, huge dump of Python and run the processor over it and have a database where I can just sort of like introspect a little bit. And there's, this is the CScope interface itself, but Vim has interfaces to CScope.